Okay, today we are going to learn the dplyr library. So this library is very useful and very easy to use for data preparing and data wrangling purposes. To create summaries out of in the groups within the data. Compared to base R, it's much more user friendly and it's very consistent in its outputs as well. So you will know exactly what kind of output you're getting. Compared to base R, sometimes you don't exactly know. You might get a vector as an output, you might get a data frame as an output. So here that does not happen, and that's one of the big advantages as well. So let's slowly start with this package. So the first thing we will do, and by the way, this is our markdown document, as you can see. So that's why we will have both text and code on the same page as a notebook style, and this is a coding section. So to add a coding section, you can go to here and it says insert a new code chunk. So if I'm outside of that area, if I click on this one and I can select R, so it will add a coding section for the R language, or I can use the Ctrl-Alt-I on the keyboard as a shortcut, and that's how I did it to add a coding section here. Okay, so let's start with this. So library, and for this, you make use of the dplyr library, as I said. So it's written like this, and if I run this, I will probably get an error. Okay, I did not. So I already had installed this. Now, in your case, if you did not have this already installed on your computer, what you can do is this. So you will go, and before calling the library, so before calling library and dplyr, giving the library's name, so this will basically take that installed package and make it available for you to use in your current session here, right? But if you didn't have that installed already, you will get an error. So to be able to install, we'll use the install.packages function and then give the name of the library. And this will basically fetch all the necessary files from the internet where they are located and install it. And actually, okay, I didn't want to run this. So because I already have it installed, so I'm not going to run this. But on your end, you should do this line. And then once this is installed, you do not have to repeat this the next time. So comment this out so that it won't, rerun the next time you go in here and try to run it. You should be able to just call the library like this. So now I can make use of that library there. Okay, so, and the other library that we're going to use is called the NYC Flights 13 package. So this one, NYC Flights 13. So this basically contains a few datasets regarding flights out of New York in the year 2013. New York to US domestic flights basically. So that's the purpose of this package. So let's try to call it, and this, I don't remember if I had it installed. All right, I already have this too. So in the same way, if you want to use this for the first time and if it is not installed, you can do install.packages, open close parentheses, open close the quotes there, and write your NYC Flights 13. And make sure you write it correctly. So if you miss this S, for example, if you just write NYC Flight 13, you will get an error. Or it might be such that there is another package called NYC Flight 13, and you will basically install that package. So that will be a wrong thing to do. You need to make sure that you write the correct name and the correct spelling. All right, so I have both packages now. So let's continue. So there's a dataset within the NYC Flights 13 library called Flights. I just run this. You'll see the first 10 rows, and it's a pretty big dataset. There is 336,000 rows. 336,776 to be exact. And it contains information on when the flight happened, whether there was a departure delay, whether there was, what the arrival time was. So these times, as you can see, is probably written in 24-hour format. Whether there was some delay in the arrival, carrier name, It's not the full name, it's the abbreviation they use, the flight number, the tail number, origin, destination, airports. Again, these are codes for the airports, as you can see. So JFK is the New York JFK airport, and I don't know, ATL is probably Atlanta, ORD is O'Hare Airport in Chicago, and so on. The distance between the two cities, so origin to destination, how long did it fly? How long is the distance in between them? The hour, the minute, and then so this is again regarding the time of flight that happened. And this is exactly in the datetime format. So if I go onto this dataset, if I click F1, you can see some more information here in the help menu. So if I make it smaller, so it gives you more information about each of the variables in the data. So for example, carrier is a 2-letter carrier abbreviation, distance between the two airports in miles. So these information are all very important to know. And it gives you a quick overview of what the data is about. Okay, let's close this for now. Let's continue here with the dataset. So let's do some quick small checks. The class of this flights data is, so let's check the class of this flights dataset. You see a few things here. So first of all, it is a data frame, and you see that here, but it's also a TBL and TBLDF. So this TBL is kind of read as Tibble in dplyr. These are actually the same thing, so it's kind of its own format, a bit more maybe nuanced for dplyr. So some, I'm not sure what kind of advantage it provides for dplyr, but it's basically a data frame and a bit of flavor added by dplyr to it. But at the end, this is a data frame. Okay, so there is no difference than our basic data frames that we have already seen. So let's, we can again, already we have seen like first 10 rows here. We can still, let's do this. Let's check the first 6 rows with head, and also can do the same thing with tail. These are quick sanity checks to see how the data looks like. So there is, for example, missing values. We can see that with the NA values here. We go to the right. There's missing values. There's missing values in the tail now. Airtime, so how long did the airplane stay flying? I guess that's what it means, the airtime there. So it seems at the beginning we don't see much missing values, but towards the end there seems to be quite a few. Another thing we can do, again, we can just use the str function. Go down here. Okay, str flights. It gives an overall summary out of the data. So you can see how many rows and columns there are. These are integer types. This is a numeric type for departure delay. There are some character types, as you can see, for the carrier name. This time hour at the end is a POSIX CT, so this is a date time format. And yeah, you see overall how the data looks like, and also the variable types. If you pay attention, you can also see the variable types here under the column names. Shows what type they are. These are important to know. Okay. So they are there. So now let's start with making use of the dplyr library. So first we will learn how to do selection of the columns. Okay, so for that, so the functions in dplyr are also referred to as verbs because they basically do an action on the data. So first thing, select. So select is used to select the variables you're interested in, especially when you have larger data set or wider data set like this, where you have quite a few columns. You might just want to see just a few for whatever reason. You want to, you might want to just see those values and maybe do something on them. So for that, we'll say select, or we already said that. So the first input is going to be the dataset name, flights. And the next one is going to be, for example, you're interested in seeing only the origin. Let's do that. If you do this, as you can see, only origin is selected. Okay. We want to add more to this. For example, we want to also see origin and destination. So we can add more with a comma in between. You can just, continue with putting the names of the columns that you want to see. For example, we are interested in also seeing departure delay. Let's put that there. So departure delay. If you run it, you can see 3 columns now being selected and shown to you. Now, for example, you could save this, right? It says 336,000 plus rows. So basically all the rows from this original data are selected, but only 3 columns are selected. So that's why you have this 3 here. If you were to select, save this into, let's just call it df for now. Now you will have another data frame in your system, in your environment, which is called df, and df only contains these 3 columns, as you can see. And from now on, you can maybe do something with that df if it's something important to you. So take this and let's do this, for example. So this notation you see here, this is called the pipe. Okay, and there's 2 basically symbols here. One is the straight bar, or also kind of referred as pipe on its own. It's the key right on top of the enter on your keyboard, and this is greater than sign. So if you put them next to each other, what this will do, it will take the output of the thing on the left, and that output is going to be used as input on the function, in the function on the right. So you remember head will, as first input, it should take the data frame name, right? So this select on the left is giving us a data frame, and that data frame as output from select is being used as input into head function here as the first entry in that function. So basically whatever this output from here is goes into here, right here where the cursor is blanking right now. And it's going to be used there as input into the function on the right. So so this notation is a bit new. The more common one is like this. So if you see this out there, this is also very common, percent greater than percent. Before it was like this. They recently added this one. So this, as you can see, percent greater than percent is still valid. You can still use it. This is a bit new. So if you were to look out online for different resources, you probably will see both. And I will assume in a bit older, let's say older than a 1 year or so documentation out there, you will see this more common, and this will be, this has started being used by people more and more. I will try to use this one. I'm not very used to it myself, so it might be hard. Sometimes I might just go back to this one because it's just when you get used to something, it's much easier to use it in that way. So that's why I might continue with this. And if you see this in my coding, that's still okay. Just I'm letting you know that both are valid. Both are okay. Okay, so that's selection there. Now, just the same way you want to select something, it might be that actually you don't want to select something, right? So let's say select the dataset name flights, and actually let's say we are not interested in selecting okay, so let's do this. The dataset itself is well, okay, let's just for example, let's look at the dataset name columns here. Let's say this flight number, this is not very much interesting. The tail number is not very much interesting. Let's do that. So let's say minus flight here, and let's see what happens. If I run this, if I go to the right, you will not be able to see the flight column anymore, as you can see. I want to get rid of the tail num as well. So let's add that, comma, minus tail num. let's go to the right. So flight is no more there, and tail number is also not anymore there. As you can see, it's gone. It's not anymore shown to us. So with putting minus, we basically tell R that we do not want to see those columns there. If you keep adding more and more columns like this, another way to do this is you can just combine them in a vector. So put a C around them, right? And then get rid of the second minus here. So we are saying basically we are creating a vector of flight and tail num, and then we are putting this minus in front of them. And we are telling R that we do not want to see them. So let's run this. So it will have the same effect. We will not see flight and tail num to the right here. As you can see, they were somewhere here, and we are not seeing them anymore. Okay. So another thing I want to show right now is this. So after seeing this notation, one of the main benefits of this is that we now can use many functions one after another without nesting them inside one another, right? Because we can take the output from the left, we can put it as a first entry into the right function, and then we can continue like this. So we can actually use many more functions, right? So one use case would be, for example, this dataset. Instead of putting the dataset as the first entry, we can go here, we can use it here, we can say flights, and then put the pipe notation, and then we can say select. So basically now flights will basically transfer it over to here, because this notation will take the output from here, which is flights on its own. We didn't do anything on it, and it will be used as the first argument in the function in select, right? And then we can, for example, we are interested in origin and destination. So if I run this now, you can see it works fine without any error, because basically we are saying, hey, take this, put it here as a first entry, as the first argument, and then apply your, whatever you need to do. So in this case, it's selection of the columns, and it's selected origin and destination for us. So we are good, okay? And that's it pretty much for the select verb.